Hello everybody, and welcome to episode 13 and final episode of SpaceShooter. In this episode, we'll fix up some bugs and hopefully leave you up to a good start on your own SpaceShooter. So first thing first, you may have noticed that the pausing in our game. Wait, let's start at level 1 actually. But this is the wrong text. Let's start at level 1. Oops, that's the wrong thing. So you may have noticed that the pausing sometimes doesn't work. So right now it works perfectly fine. I can pause it. I can shoot at this person. I can pause it. I can pause while I'm shooting and see the bullets not moving, and so it works perfectly fine at first level. Okay, let's go to the next level. Something weird just happened, but not too of much importance. We'll fix that later. So now let's try the pausing here. It works too. Level 3. Yikes, the pausing doesn't work anymore. I'm pausing it, but it doesn't work. And it doesn't work. It does work here. So this is just getting really strange. Does it work here? Nope, it doesn't work. So we want to always be able to pause the game. So that's why I built this method. So this method has its own variable here, long request pause time equals system dot current time millis minus 500 and public void request pause if system dot current time milli is greater than request pause time plus 500 pause equals not whatever pause is not, and system dot print ln pause. And key input, let's move this up to the top from key release to key pressed, and game dot request pause. And now when you run it, pause, 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 pause. Bombs. Next level. Weird stuff happened. Pause. 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 Works. How do I kill them all now? Okay, I must kill them all first to show you it works, like for every time. Wow. Okay, that didn't work. We need a bigger number. It's also quite possible that the reason this is that we're ticking too quickly. So change that to S64 if you have it at 100. Should work. And let's just kill them all. Okay, I think that still didn't work. No. Oh! Okay, I figured it out. So the reason is we need to change request pause time, and this can become a 10. It can be a small number, but it has to be equals to this. We never updated the time. So now when you run it, it will finally work. After years of hard work, this works, and change it back to 100 because it feels better. Pause, 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 pause. Pause. Attack, 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 attack. And also, I want to add on something. So you may have realized that when you pause, you can still make a bullet appear and shoot it once you unpause. Let's fix that. Simply move that up. Put that in brackets. So we don't want input or get O handler ticks. Don't want neither of them to tick when it's paused. And so when we pause, we can't really shoot and we can't really do anything. Pause. And let's try the knife trick. Yep. So that's fixed. Let's move on to the next problem. So as you may have realized, and now you should have by watching my video, you may see that sometimes level has nothing in it. But if you read all the levels, there's always something in it. Okay, let's clean this up. And that's partly, actually, totally due to the loader. So let's read the readme PE. Pause. Loop SE. Okay, just add that bit. So what do we have in this loader? Whoa, this is the wrong readme. This is the correct one. I was doing the other project, which is exactly the same as the one I'm showing you right now. This is just to plan what I do. So let's say our little method right here. So basically it can contain 3 of these. Perfectly fine. 1, 2. Okay, so let's see which ones do not work. Okay, level 0, that works fine. Let's say next level. Level 1 doesn't work. So, let me write that down. Paper, my paper. 1, 2 works. 3 works. 4 works. 5 works. 6 doesn't work. 7 works. This is gonna take a long time to kill them. 8 works. 9 also works, I mean. Correct grammar must be used in YouTube. 10 works, 11 works. 12 works not. So 1, 6, and 12. So what do they have in common? 1, 6, and 12. 12 has this statement that I haven't programmed into our loader yet, so we can ignore that. 6 doesn't seem to work. And there is 1. So what makes them different? So let's delete these. Don't need that. So let's compare to 10. It seems that they do not like these things. So, and all the files, like, remove these thingies. Oops. Oops. Made the exact same mistake as last time. So now when you run this, it still happens like that. Okay, I'm gonna pause the video and figure out what's wrong. So yeah, I found out a problem. We were multiplying this by 3, or I was, because I give you the code, so sorry guys. But hopefully you'll forgive me for my complete stupidity. So yeah. So it used to be like this, make it not like that. So, now why is not the third there? We can run the program right now, and the game is not the right one, actually. Okay, this works. So, it works, and we're happy. I was getting confused of what was happening wrong. So now, back in our levels, we can see that level 12, there is this thing, and it is actually something, believe it or not. Basically, in the readme, maybe we could add like 2 more stuff, but in a little, what that actually means is simply make the boss in level 12. The boss in level 12 is actually just draw something so we can understand it better. It's like a bunch of squares. What is a square? Basically, it's a bunch of squares that are like together, and they bounce around together. And so that's what I do. So we want to have that too. And so what each of these instructions mean is 200 for the first position, 100 for the second position, X and Y of the head, tail actually, X and Y of the tail, the 250 for the 250 for the, oh yeah, no, it's actually 100 for X and 250 for Y. The 200 is how many enemies that boss is made out of, and these are just the spacings. So we don't want them to be all like squished up into like one box, like they'll all be like in one box. The first enemy will be here, the second enemy would be here, and they'll all be in the same position. That'll just make it impossibly hard to beat enemy with bullets, but it's too easy for other weapons. And they're all in the same place. That's not really fun. What we want is like they be in different places, so it will look like a snake of some sort. And so like a snake. Some sort like that. We don't need that image actually. So all I do is if type is equals to loop se, we can simply type in enemy equals enemy, the x as x. Wait, we need a loop here. For, let's just make a list of an int list data, so we can store all this data in a list, which is actually an array, but they call it a list because it's a list-ish thing. Let's 5 in it. For every single data member, that means for int I equals 0, I is less than data dot length I plus plus. This then they're looping through a list way. Data. What just happened? Okay. Data brackets I mouse out equals scanner dot Next, int. And now for data for int I equals 0, I is less than data 0. You guys remember, this means how many segments the bus has, so we want to loop through that number and make a new enemy every time. I plus plus and let's make an enemy equals new enemy data. I can't spell data today. Strange. Data 1 plus data 3 times I. So basically it is the x coordinate is the tails x coordinate plus the tails x coordinate plus the offset, and since every enemy's offset is one offset more than the previous enemy's offset, we just do this simple multiplication times I, and yeah, the y coordinate is really similar, except instead of data 1 it's data 2, instead of data 3 it's data 4, and the h is just there for some reason. Okay, now we can simply change the health of this creature because it's a boss. A boss is supposed to be very powerful. So let's just make it 50, 10 times more than usual. A dot. Okay, now we can just add it to the handler. And then we're done. So let's check this out. I think turning this into a 12. Oops, I did something wrong. There's an S there. Okay, let's try to defeat the boss at level 12. What bombs? It's most not easy to defeat. But we beat him. Actually, that was so easy. Make his health 200. Pause. Yay. The pause works. Okay. So that's that. Now you may have noticed that we have unlimited amounts of bombs, it seems. So let's change that because the game will be way too easy if we have unlimited amounts of bombs. So let's make a private int ammo equals 50. And if ammo 0. We can complete the whole task right here. Tab. And what's minus is just to save a line of code. And to make yourself look smart in front of your friends. So now how many bombs do you have? 5 of them. Okay. So finally, this is the last thing we're due before I'll leave you on your own. Oops. I implemented a new sword that can do this coolness. Basically, all these little glow wings things are also swords. And it was meant to be like particle effects, but then it didn't really work out. So, but it still looks really cool. So I decided to keep it and show it off. And I'll teach you guys how to code it. So as you can see, it's probably really similar to the sword class, because it has trigonometry in it, and by trigonometry I mean it uses trigonometry to calculate the distance from the center of stuff. And it can also be boring. And also has like lines that attack the enemy. So it's actually quite similar to it. The way I made it, I just copied all the code and normal sword and just like change it. I changed maximum of 20 lines of code and it was that. So let's just do that. Let's create a new class called complex sword, because it used to be a simple sword, now make it complex sword. Weapon, okay. Sure. And let's copy the code into the sword. I think you actually copied the code from Civil Sword to your code, so I'll explain what some of this does. This is the constructor. In a constructor, oops, it's already a sword. We just create the line that will be a sword. Sword is actually a line, so don't judge. Some lazy initialization. I'm not sure why I'm using a lazy initialization, probably because I'm lazy. I don't know. The attack, basically attack frame. So if the attack frame is correct, and if it's player's not, if the player's null, get out, you're not supposed to be here. Then we convert the data to stuff to set our line, set the line, and check if it hits anything and hurt the enemy that gets hit. So, all's well. Okay, so in the complex sword, you have seen that there's more than one line. So that's precisely what we're gonna do. We'll make more than one line. Line to the list. Lines. So make a private int as well as the line list. Int num equals 20 private static final, and so nobody will ever change it. And then we can simply initialize lines here equals new line to the list none. This is a random S there. Okay, make it 2 times that speed. Actually, just make FC twice as it used to be, so that we can actually see the sword growing. Copy this. So right now, we're just making the sword grow when you press space until it's at max length. And here, we're just making the sword shrink. Until it's smallest in a row. So basically this is making the sword grow, and it's also shrinking at the same time. But if we make it grow, it'll shrink less. If you get me, you probably don't. I don't understand myself either. But this is what happens. So we shrink the sword. And we convert this player status. So now we've got to change this into an angle. So as you can see, the sword is rotating around the player, so we need to keep track of the angle, right? So let's make a double data. And convert player stats, let's change in I and J into another thingy. Make it a double angle and full white. And this is not going to work. So just returns new. I can't type. Double. And so we're gonna use trigonometry to figure this out. If you do not know trigonometry, don't worry, I'll be explaining it a bit. I also just understood trigonometry, so don't really worry. If you don't understand it, well, I'll be typing the code along with you, so you don't have to like figure it out on your own. Math dot. So the first first variable inside our double array is x coordinate. So we just use the math of cos math dot 2 radians angle. So what does this mean? Back in gym, make a new thing. Okay, so this works. Circle, red circle, fill in red circle. Pencil. That is black. Okay. So let's make an angle here. Okay, this just looks horrible. The pencil's too fat. So we have an angle here, and it's 90 degrees. And let's make another angle. And it's an angle that's horribly fat for some reason. Okay, so the angle that is here is theta, and so cosine is equals to, well, cosine of an angle, let's make it t, is equals to the, well, ADJ, standing for adjacent, over height, standing for hypotenuse. So if you don't know what, magnify it a bit more. Okay, this is too magnified. Okay, this is perfect. Okay. So the cosine of t is equals to its adjacent divided by hypotenuse. So let's make a circle. What? Not a circle. Let's make a triangle that I can draw on. Why can't I draw? Okay. I'm on this. Okay. So let's make a triangle right here, randomly. It has to be a right angle triangle because that's what the whole thing's about. So in this, so the longest part is the hypotenuse. It's got a hypotenuse. This part. Okay, so, and we need to figure out what t is. So let's say this was t. This is t. And so this will be the opposite. Because it's opposite side of t, you see? Like it's the opposite. Like we could slash and t will be on one side and opposite will be other side. And this is the adjacent. Basically it's the side that's touching the t that isn't hypotenuse, the longest side. And these things only apply to right angle triangles. In trigonometry, it's all about that. So yeah. So cosine is t. Cosine of t is equal to adjacent over hypotenuse. But would we ever want to know any of that? Okay, I need to clear this. Okay. So let's make another circle that is red again. So let's say we've had a center point. Whoa, this is red too. We want to figure out how would we like draw an angle that's like angle. Let's say this angle was, I'm using text. Like, what does that look like? A 30. It looks like a 30. So let's say that was a 30. We want to know how far should this go until it reaches the end of this triangle. Like So how far this should go. And it is here. I'm a horrible artist. Please forgive me. So it reaches here. Should. And how high does it go? Well, it reaches here. So we need to figure out the x and y coordinate to draw the end. So maybe we usually don't have a random red circle lying around with us, so we have to figure it out on our own. Oops. We usually don't have a magical circle, so we have to figure it out on our own. And the circle's still here. Okay, now it's gone. So we need to figure out where does this go. So that's when trigonometry comes in handy. So this is our angle, right? Our 30. This is just like the thing I drew just now. T, hypotenuse, opposite, and adjacent. So basically, with cosine, it's adjacent divided by hypotenuse. So hypotenuse, so let's say this was a sword. We know how long it is because we want how long it is. In our case, it's 100. So hypotenuse is 100. I should use these more often, actually. So hypotenuse is 100. So to figure this out, we can simply say x equals cosine of t times 100 because of basic algebra. Right. So adjacent is basically our x coordinate now. So with our x coordinate right there, adjacent, we need to figure it out. So the cosine of t, our 30s are t, 30, and hypotenuse we already know it's 100 because that's how long we want it to be. We're figuring out adjacent from hypotenuse and t, which is 30. So this can be calculated with a calculator. So the cosine of 30 times 100 is 86.6 025400378. So that's how this works. And we have our x coordinate. Now we need our y coordinate. Luckily, sine is here. Sine t equals opposite divided by hypotenuse. So opposite is quite similar to our y we want. So we can simply say y equals the sine of, am I even recording this? Yes, I am. This is good. I haven't wasted all my time. Sine of 30, which is t, but we just substitute it for 30. It's really simple algebra here. Times 102. So we've got this and that. We have our x and y coordinate. That's all we need for figuring out this point here. Okay. So back to Eclipse. Convert player stats. We want it to be theta. So I used a plus equals 5 to make it my sword rotate like that. So we can see now method cosine of angle times length. Now you can understand that that is actually figuring out the x coordinate. And method to radians is simply because computer trigonometry uses pi instead of 360. So it simply figures out the ratio of 360 to pi and multiplies our angle by that. Now math.sine for the y coordinate, math.2 radians to multiply it by the ratio, and angle 2 times 800, and that's it, solved. And so, let's test out a sword before we improve on it further. In the player class, let's make a new complex sword. And we must make a new weapon type because we haven't weapon type it yet. Super sword because it's better than that sword here. I am better than you. In the player class. Okay, back in the keypad class, we need to add that there. Or it'll be super sword. Super sword. Okay. So now let's try it out. With 4. Whoa, this is the wrong thing. Again. Why is it not responding though? Oh, it's super sword. It's just flashing, they're not moving. Let's just keep the complex sword from shrinking back down then. Because there's a couple numbers I might have messed up. So, yeah. Why is it so small? Oh. Okay, I figured something out. The length shouldn't be there inside the function. It should be outside of the function. I mean, method. I'm speaking in C++. No. Okay, now we have a spinning thing. And okay, we've got our sort of eternal doom that spins around and hits stuff. And seems pretty effective at killing stuff too. The enemy's quite terrible at attacking me apparently. I'm swimming at them. Yeah. So that's the sword for the first part. Now for the second part, the particle effects and the particle attacks. Basically, this is what these lines are for. And I don't need this. So what we want is for every single line to become the next one, and then for the final one to become line. So basically, here's what we do. If what line, that. For int I equals 0, I is less than num minus 1, I plus plus. Remember, the num is how many particles we have. So right now we have 20. So lines I would be equals to lines I plus 1. That is, if lines I equals null, continue. Equals null. And so we're just simply adding on if it is not that. And lines num minus 1 will be equals to new line to be line dot get P1 dot get P2. We can't say it will be equal to the line because that's double. Lines. We can't say it will be equals to line because it will be a reference to it. We must create a new object that is always equals to line and then assign that to lines number 19. So let's render them. We won't be able to see them, right? So we can have this out. Okay, so for every line and lines, we want to draw them if they're not null. So if lines I equals null, we just continue. And we can draw. We cast it into a graphics 2D so we can draw it. Okay, now let's draw that. Right now you can see there's 2 of them. I thought we ordered 20 of them, Break, maybe? Nope. Continue. Oh, okay. We don't actually need this check here. And move that up there. Okay, now we have our fan that we've been waiting for a long while. Although these can't attack and they're not as transitional as they could be, because last time we saw it, it's smoothly disappeared. This is a bad position. Pause. As you can see, this is the brightest, and they get dimmer and dimmer until they reach the end and become invisible, basically. So that's what we want to do, and also make them able to attack. Let's do attacking first. If it's an instance of enemy, sure. If dot get balance intersect. Oh. 4 2D L lines. First check if no L equals no, continue. Otherwise, if it intersects L, intersects line L, then copy that bit of code. And now, all we have to do is to set the color to stuff. G dot set color, G dot get color. Well, first build a new color. New color. Dot get red. Get blue. And get green. In fact, it can be color actually. We already have a variable with us, so and what we need now is say int alpha It goes to 55. We'll simply return an alpha minus equals to 55 divided by num minus 1. Wait, let's try that first. Divided by num. So now let's run the game. And you can see the smooth transition now. When we pause the game, you can see the smooth transition. And we can add some more of these if we want. Wait, I'm running the wrong one. And you can see it's super slow. Doesn't rotate really fast. And I think it's because we're not ticking fast enough. So back in the game. How often do we tick? 100. Oh, and I figured something out. Well, I found something out. Basically, we don't want to have render inside a while loop. So, in the third episode, I said to put it inside a while loop. Now, I'm telling you to put it outside of a while loop. You may be getting confused, but just listen to me right now. It may help the program work better. See, it's much faster now. Okay, so basically, that's what happens when you make complex sort 40. Did I do this wrong? Okay, complex sort. Yeah. It should be 20. Don't make it 200 as I did. But 20 is pretty good. I found a little sword that looks deadly and probably is. It killed a boss in 5 minutes. 5 seconds. Wow. Its attack is strong. Okay, back in a loader. I think it's supposed to be 500 there. Okay. So, finally, I'm gonna teach you how to build your own levels in this game. So, what you do here is create a new file and name it level. And so, we have a level 12. It's a max level right now. So, name it level 13.text. And finish it. Now, wait. Before we do anything, actually, in the loader, we should add one final if statement. And add a window W inside its parameter list. If type equals t w dot what can our window do? Set subtitle. I think I put the wrong window. Set subtitle scanner dot next line. So what happens? Wait. What happens now? Save this. Once we load a level, we need to put in our window there. And okay, back in game. Remove that bit, comment it out. Okay, so you can see now that we've got the title of the game there and the subtitle. So once we kill him using a brand new cool sword, the title changes because we want more sword. Next level, disable them up. I'm just gonna slash at them. It's millions of swords. Magically up here. Next, title changes. And so yeah, the title can change now. Okay, now back to teaching you how to do this. To make a level, simply type in T for the title and write about anything you want, like one enemy to rule them all, and loop SE 500 0 0 1 1 and play level 13. Then you can change level number to your level. Oh yeah, no player level 13, and player is at 0 800, I guess. Wait, the player's outside the screen. 600 then. Okay. An enemy. And a player. Okay. Okay, happy now? Okay, so yeah, I think you're supposed to put the player on top for this work. Okay, so right now we've got our game. UBC 500 50 1 1. Okay, now let's try it out. Oops. P 50 0. Oh, capital E. Okay, so here's our player. Here's the sword that's pretty much unbeatable. And yeah. So to make a game, I'll update this. S-E. So I'll have all the instructions here. Inside our readme text, and I'll update it so you guys can play around with this. And also, I'll give you an updated loader file so you can even load even more stuff, because there's even more stuff to load. So thanks guys for watching till the last of SpaceShooter. Please leave a like and leave a comment to tell me what to do next, and have a great day. Goodbye.